Okay, Natalie, Jada, are you guys ready over here? It's all about me. It is always about me. Okay, so everything, all of the plotting we've done so far, it's always been on the coordinate system. It's the rectangular coordinate system, and we use the x and the y. So we do this to define a point in space. The Cartesian or the rectangular coordinate system, we use the coordinates x and y, and x moves horizontally and y moves vertically. So they meet at point x, y. And we call this point the origin, and it's 0, 0. The origin? Yeah. But if you look at this, what's the difference between this and this? It's a circle. And why do you think we're switching to circles? It's not because I hate you, but it's because we've spent all year doing the unit circle, right? Which is a circle. Yes, we have. So instead of moving vertically and horizontally from the origin, we use the distance from the origin and the rotation angle. So for the polar graph, the center point is called the pole. That's like the origin, okay? So this right here is what we call the pole, right in the middle, okay? So the plane appears this way because the polar coordinates are given as a radius, r, and an angle, which we're going to call theta. So each circle represents one radius unit, and each line represents the special angles from the unit circle. Like pi over 4, pi over 3. Okay, it's our special angles. So the only vocabulary we have so far is, instead of this being the origin, what do I call this? The pole. Okay, that's the only thing. The other thing I want you to remember is when we talked about vectors, when I talked about a negative vector, what did that mean? You all got this right. It's about the only thing everybody got right. So the negative vector, if it's going this way, the negative means it's going the opposite direction, right? That's the way the radius is going to, bless you. That's the way the radius will work on the unit circle. All right, so we're going to write all points on the polar plane as r theta. We're always going to start with theta first, and then we'll locate r. Always theta first, and then r. So my first point is 2 and pi over 4. So which one did I say we have to start with? Okay, because that's how you write it, r theta. But we're always going to start with which one first? Theta. So in this example, what is theta? Oh my gosh. Pi over 4. So this is always 0, right? So if I go to pi over 4, this is the line for pi over 4. And what was the r? 2. So I'm going to go out a positive 2? Yes. Now, okay, so before, just let me explain for a minute too. So if that was a negative 2 pi over 4, negative 2 pi over 4, all right? So I would still, we always start with theta, so I would go to theta, right? But a negative 2 means go the opposite direction, right? So that means I have to go through the pole and go out 2 in the opposite direction. Okay? So negative 2 pi over 4 is just, you go to pi over 4, but you go through the pole and go out 2. Does that, everybody sees this? Okay. So this one is negative 3 pi over 6. We always start with theta, and my theta is what this time? Pi over 6. So here's pi over 6, but what is the radius this time? That means I have to, on the pi over 6, I have to go through the pole, and now I'm going to count out 3. So it's 1, 2, 3. So here's the point right here. Oh, sorry, guys. It's hard to see up here on the line, sorry. This one. There. Thank you. Okay? So we're just going to stay on the line, though. Right? Okay, what's the next one? So, negative 2 pi over 3. So first of all, negative 2 pi over 3. How many degrees is that, friends? Not even. Pi over 3 is how many degrees? 60 times 2. So negative 120. Bless you. 105 and 120 are not the same. Just, all right. Okay, so if I'm going negative 120, right? So this is negative 90, and this is negative 120 then, right? This is another 30 degrees. And what's the number? Is it positive 2? So then it's right here. I said, is it positive or negative? Yeah, it's positive, so it's 2. That's right. Yeah, yeah. Okay, it doesn't, so listen. So we start with the theta, right? And that means negative 2 pi over 3 went this way, right? So it's positive, so I'm not going through the pole. So it's here. But if it was a negative 2, negative 2 pi over 3, then I would go up here.
We only go through the pole when it's theta, not theta r, right?
When the r is negative, you have to cross the pole. No. Okay, so the theta, so these are good questions. So the theta being negative, this, if I move this way, I move positive, right? If I move negative, I'm moving this way. So the negative in front just moves me on in the circle, that's all. It just moves me up or down. The negative r moves me through the pole. Is that, yes? Okay, you guys graph the next 3.
So then whenever the theta is negative, you go the opposite.
Cardarius, you can actually get out of your chair.
I don't want to get up.
Get up anyway. Let's go.
I feel like I did it.
That's all right. Let's look at it.
It's like super easy that it's like ABC.
Yeah, none of it.
Mine's are confusing because they're so close together.
Wait,
So it's 7 pi over 4 and 4. Perfect. Perfect. That's, yeah. All right. Okay. Can everybody plot these last 2 now on the, it's just the last one. We have one more thing to do.
On this new circle, right?
Mhm.
This new circle.
On the new circle, plot the last two.
They're on each other, right?
They are. They are on each other, correct? That is because for every point you plot, there's 4 different ways of naming that point. All right? 4. So, listen carefully. So this one was 2 and pi over 4, correct? So the next way also has a positive 2. The last 2 are going to have a negative 2. So, yeah. So listen. So every time you're given one, there's 4 different ways that you can name a point. I can name 2 positives and 2 negatives. So I'm just going to start and write that down. Now, I have pi over 4. If I go this way, it's pi over 4, right? If I start here and come all the way around to here, that's a negative, right? So here's the thing. You don't know these off of the top of your head, do you? Oh, Isaac does, so he's going to be good. So, Isaac, you're not going to have to worry about the shortcut I'm going to give everybody else. You can just name this off the top of your head, okay? But for the rest of us, in a unit circle, I have 2 pi all the way around, correct? So if I have 2 pi all the way around, but this is a 4 on the bottom, so this would have to be 8 pi over 4, right? Yes, right? So I just multiplied the 2 times the 4 and got the 8 here. So I know that this plus this have to equal 8 pi. So it's 7 pi over 4, but which direction did I go? Negative. Is that hard? No, it's not. So now I want to use a negative 2. I want to use a negative 2. So if I know this is on pi over 4, if I come across here, it's 5 pi over 4, right? So this one is 5 pi over 4. And then what would the negative direction be? This still has to add to 8. It would be a negative 3 pi over 4. Okay. This one? Okay. So if I do this one right here, okay, just like pretend I didn't find this, all right? 5 pi over 4 takes me all the way over to here, and the negative 2 brings me back to this point, okay? So when you're given the first one, if you remember, on the line, they're the same reference angle. So this is just going to give me my negative. I'm just going to go across the pole back to the other one. So when I started at pi over 4, if I come all the way across, it is 5 pi over 4. And then I found the negative one because they have to add to 8 pi. Because the one is the positive and one is the negative. Okay, I'm going to do one more with you too. You're going to have them with a graph. Okay? So everybody look at number 11 on your worksheet. Yes. Okay. Can you start, can you not whine before I'm even done? Number 11. So what's the point they give you for number 11? 2 and what? Okay. Okay. So I'm going to start with 2 and 3 pi over 4. So I know I'm going to do this to start with. Yep. Just 11 on. Okay? Okay. So I can't draw the lines for you. So So I know I'm going to start this way. So it's a 4 on the bottom again, so I know I have to have 8 pi over 4. So if this is 3 pi over 4, this one is negative 5 pi over 4. So if I do my theta first, I come over to 3 pi over 4. What's the same across from it? 7 pi over 4, and then a negative pi over 4, because they have to add.
Is that all we have to do instead of like?
Yes,
How do you know, like, why do you get to 8 pi? Like, is that number?
because it's 2 pi, and this is 4 on the bottom. So if this was 3 on the bottom, it would be 6 pi. Okay? Okay. If it was 3 on the bottom, it would be 6 pi over 3.
Yes, 2 and 0 degrees.
Okay. Okay. All right. So next, I do want to say I did all of them in radians because y'all hate radians the most. But if it's in degrees, right? If it's in degrees, how many degrees are in a circle? 360. So if I told you one of them is 180, the other one has to be a negative 180, correct? Okay, so the degrees is just the 360. You guys can do the degrees.
Can you do 1?
Do one of what?
Degrees. Like number 12.
What is it? What's the numbers? So it's going to add to 360. So I'm going to have I don't know, what number is it? 12? So this would be negative 255. I just subtracted from 360. Now, I always start with the 105, right? That's your theta. And so if I start with 105, 105 would come around 90, and it would be over here, right? So it'd be how many degrees past 90? 15, right? So what's the same one down here? Bless you. It would be 270 plus 15, right? So that would be 285. So this one would be 1 and 285, and then a negative 360 minus 285. Which is what? What is this? Is that right? Okay.